Okay, y'all, we're going to go over day 54. This is a review for the final. This is kind of like the second half of the final, where we look at what we did for test 2 and test 4. I'm sorry, test 3 and test 4, okay? Guys, first we talked about factoring. This first one is the greatest common factor. Again, if you recognize, guys, between 70, 30, and 70, I can take out a 10. And I'm going to take out a negative, okay? And there's 4 x's here, 5 here, and 7 here. So I can take 4 x's out of each one. So the greatest common factor is negative 10x to the fourth. So just divide each of those terms by negative 10x to the fourth. And that's what I end up with, okay? Number 2, again, greatest common factor. Guys, I can't take a 2 out of this middle term, so I can't take a 2 out. But I can take x's out of each one. There's 1 x right there. So I'm going to take 1 x out of each. And there's 1 y right there. So I'm going to take 1 y out of each. So take out an x and a y. So divide each term by x and y. See what the answer is. Guys, number 3 is the simple factoring. Again, if you remember I take the first sign, the negative, put it here, and the second sign means the signs are different, that negative. 54, what is that? 9 times 6, all right? The difference between them is 3. Just put the little one here and the big one here. Just make sure that you do that. All right, number 4. Again, this one has the greatest common factor. Take that out, the 3. It'll be the number in the front. Take that out, so then you have an easy factor here. Again, you put your x here. First sign is negative, and that means they're both negative. Both signs are negative, right? It's 2 and 7. 2 times 7 is 14. 2 plus 7 is 9. All right, number 5. This requires the slide method. So I have to slide back the 9. 9 times 24 is 216. Oops. Sorry, guys. The slide method, slide the 9 back times 24. Has no greatest common factor, so here we have to slide it. All right, so I slid it back. It looks like this. So now we can simple factor it. It turned out to be 54 and 4. 54 plus 4 was 58. 54 times 4 was 216. Okay, divide out the 9. Remember, divide the slide. So 54 divided by 9 is 6. This one bottom up the 9, so it's 9p minus 4. Okay. All right, number 6. Then, guys, this is a perfect square. All right? The square root of 9x squared is 3x. And the square root of 25 is 5. Guys, the signs are both the same. They're negative. All right, that's it. All right, this next one, guys, is the difference between two squares. It's a quadratic, but it's only 2 terms. So again, the square root of 16x squared is 4x. And that goes here and here. And the square root of 25 is 5. And that goes here and here. Remember, one's a plus and one's a minus in this case. That's how the middle term disappears. It's not a perfect square. All right. Number 8, identify the vertex. Again, guys, the opposite of what's inside, exactly what's outside. That says plus 4, so it's negative 4. That says plus 8, so it's 8. All right. All right, this one's in standard form. You can put it in Desmos and look at it and find the vertex if you want. Or just, again, use the formula. H is negative b over 2a. So I put it in there. I got 2. Again, this is the b. And this is the A. A is 7, B is negative 28. So negative of a negative is how I got positive 28. I took the 2 and plugged it in this original equation, and I got 2 again. So it's 2 and 2. All right, identify the vertex. Again, guys, it's right in between the 4 and the negative 2. So I can just go 4 plus negative 2 divided by 2. All right, 4 minus 2 is 2 over 2. So that's 1. That's the h. All right, put k back in there. To find k, take the 1 and put it right there. So I got negative, and it's 1 minus 4, and then 1 plus 2. So the negative is in the front still. This is negative 3, and this is 3. So guys, I have 2 negatives, so I end up with 9. All right, number 11. Again, find the vertex. It's right there. Okay, I'm sorry, axis of symmetry. Just go right down here. It goes through the vertex. It goes through at 1. All right, I'm sorry, it's plus 1, not negative 1, plus 1. And the vertex is also plus 1 for the x-coordinate. The y-coordinate's negative 4. The intercept, the y-intercept, is not negative 4. It's right there at negative 3. It's right there at negative 3, not negative 4. Like I select the graph. For some reason, this didn't print very well, so luckily that's the right one. We're looking for the vertex at negative 4, negative 3. And there it is. All right. All right, the next one is in standard form. Select the graph. Look at the intercept, plus 11. It goes through the y-axis at plus 11. Okay, it's not this one. It's not this one. This one goes through 4. But this one is going above the 8. It's the only one that could go through 11. It's got to be this one. All right? It's right side up, too, just so you know. This one's upside down. It can't be that one. All right, select the graph. Guys, this is in factored form. So the x-intercept, this goes through 6 and 1. Which one goes through 6 and 1? Right here. Here's 1, and here's 6. The x-intercept is 6 and 1. All right? When x is 6, y is 0. When x is 1, y is 0. All right? The vertex form. Again, guys, there's the vertex. The vertex, the x-coordinate is 3. So I want x minus 3. The y-coordinate's negative 5. So I want negative 5. Okay, right there. All right, select the standard form. Guys, look at the intercept. It's right here, negative 3. The y-intercept is negative 3. All right, so which one of these is negative 3? There's one right there, and there's one right there. Okay, guys, it's upside down, negative x squared, that's it. That says negative y squared. That's not even a quadratic. It's got to be this one right there. All right, the proper intercept form. Again, guys, the x-intercept is 0 and 2. X is 0 and x is 2. That's the intercept. All right, so this is going to say x and then x minus 2. That's right side up, and the a over 1 up 2, a is 2. So this is going to be 2x minus 2. It's right there. All right, it's right side up. It's not the negative 2x. All these are negative. There's only one right side up. It's got to be a. Oops. All right, guys, sorry. I think something happened there. Hopefully we got it all. I'm going to keep going, guys. We're almost done. Guys, given the quadratic in vertex form, how do you convert it to standard form? You multiply it out. All right, this is what I did right there. You multiply the whole thing out. Just square this first. X plus 1 squared is that right there. Do that first, then distribute the negative 3. Then add the 8. All right, same with this one. To get the standard form from factored form, you multiply it out. Guys, use the FOIL method, or just you can put it in a box if you want. Multiply it out, combine like terms. Then make sure you distribute that 4 last, okay? All right, this one, guys, is standard form. How do you get to factored form? You factor it. All right, it's a pretty easy factor. I took out the negative first. Changed the sign, so it's now -6 and +8. All right, it's a pretty easy factor. 6 and 8 is 4 and 2. All right. Guys, this is the vertical motion problem. I'm going to show it to you quick because I'm running out of time. Again, guys, use the h and the k. That's what you're trying to find here. -b over 2a. This makes sure you plug it in the proper place. This is the velocity, and this is the height. At 88. 2 seconds. Guys, I'm hoping you can get these quick because I got to stop. I'm running out of time here, guys. Exponential looks like this. Linear is a straight line. Quadratic shaped like a U. Guys, these tables again, if the common ratio, these all equal 4, that's exponential. The first difference is constant, linear. If the second difference is constant, like this one, quadratic. All right, guys, that's it. I have to stop. Thank you.